Hello friends, this is Lecture Hall Complex IIT Delhi. This is a lab assignment prepared by Divyansh, Mathur, RISHABH, JANGID and GEETAGYA DUBEY, and here is our temporary professor.
Hello guys, good morning. Today in this class we will be learning about communication systems. So anybody here knows anything about communication systems? Front row guy, wake up. Switch it on. Front row guy, wake up.
Yes sir.
Why were you sleeping? You're sitting in the front row and sleeping.
यार ये माइक्रोफोन किसने बना दिया?
You got a problem with microphone? Let's see how
Yes, sir.
microphone works.
So friends, let us see how a microphone works. This is a block diagram showing various functionalities involved in the working of a microphone. First of all, the sound waves produced enter the microphone, then it moves onto the modulator, then to the amplifier via the transmitter, and then through the transmitting antenna it goes on to the receiving antenna. From there it goes on to the amplifier, then through the demodulator to the audio amplifier and to the loudspeaker. This is the cross section of a dynamic microphone. Sound waves produced strike the front surface of the diaphragm, causing vibrations. These vibrations are converted into electrical impulses and are carried by wires. In electronics and telecommunication, modulation is the process of varying one or more properties of a periodic waveform, called the carrier signal, with a modulating signal that typically contains information to be transmitted. What a modulator actually does is that it superimposes the actual message signal onto a carrier frequency, so that the transmission can be easily carried out. An amplifier is an electronic device that can increase the power of a signal. An amplifier functions by taking power from a power supply and controlling the output to match the input signal. In this sense, an amplifier modulates the output of the power supply based upon the properties of the input signal. An amplifier is effectively the opposite of an attenuator. While an amplifier provides gain, an attenuator provides loss. As we can see in the figure, the various electrical components such as the resistor, the capacitor, the microphone, the operational amplifier and the speaker are connected in proper circuitry so as to obtain the required amplification. Now let us come to an important part of the transmitting channel. It is the transmitting antenna. In radio and electronics, an antenna is an electrical device that converts electrical power into radio waves, and vice versa. It is usually used with a radio transmitter or a radio receiver. In transmission, a radio transmitter supplies an electric current oscillating at radio frequency, that is a high frequency alternating current, to the antenna's terminals, and the antenna radiates the energy from the current as electromagnetic waves, that is the radio waves. In reception, an antenna intercepts some of the power of an electromagnetic wave in order to produce a tiny voltage across its terminals that is applied to a receiver and is finally amplified. An important component of the transmission channel is the need for reamplification. The audio signal, after being transmitted by the transmitting antenna and is received by the receiving antenna, the loss of energy takes place. This is called attenuation. Hence it becomes very important to reamplify the audio signal so as to obtain the required strength.
Start.
Demodulator. Demodulation is extracting the original information bearing signal from a modulated carrier wave. It recovers the original wave which was modulated earlier.
A loudspeaker is an electroacoustic transducer which converts an electrical audio signal into the corresponding sound. As we can see in the figure, when a fluctuating electrical current flows through the coil, it becomes a temporary electromagnet, attracted and repelled by the permanent magnet. As the coil moves, it moves the cone back and forth, pumping sound waves into the air and hence generating the amplified version of the original audio input.
Did you understand that?
Yes, sir. Thank you. I will try to make the microphone of my own.